In May 2024, skies across the globe lit up with brilliant displays of the aurora borealis, reaching far further south than usual. It was a beautiful sight, but it directly contradicted a major scientific consensus. In 2019, forecasters at NASA and NOAA, the U.S. government agencies responsible for monitoring space weather, predicted our sun was going to sleep, forecasting one of the weakest solar cycles in a century. Back in December 2019, the sun's surface was a pristine, spotless sphere. By May 2024, it was violently scarred and hyperactive. This chart shows exactly how much the official prediction missed the mark. The forecasting panel expected solar activity to peak low at around 115 sunspots. Instead, observed data shot aggressively past that trajectory, easily breaking 160. The world's top astrophysicists underestimated the ferocity of our current solar cycle. That miscalculation leaves Earth exposed to a surprisingly violent star. Late 2023 and 2024 brought a relentless wave of extreme events. In October 2024 alone, the sun unleashed an X9.0 flare, the most intense category of solar explosion, setting a record for the current cycle. These massive eruptions didn't stay contained in space. They triggered G5 geomagnetic storms, which sit at the absolute highest threat level on the space weather scale. To understand the raw physical scale, look at the forces involved on the sun's surface. These are twisting, planet-sized structures of plasma, violently ripping outward into the solar system. We are officially in what astronomers call a solar maximum. We have to ask why the sun is behaving with such hostility right now, and whether Earth is sitting directly in the crosshairs. A solar maximum is a natural, predictable phase of the sun's 11-year biological clock. At the height of this 11-year cycle, the sun's massive magnetic poles physically swap places. The north and south poles completely flip, causing the star's internal, orderly magnetic field lines to become tangled and twist tightly together like rubber bands. As the twisting continues, it creates immense pressure and turbulence. Those tangled magnetic field lines push outward, eventually breaching the surface layer to form concentrated, highly pressurized magnetic loops. When these intense magnetic knots finally break through the surface, we see them as sunspots. These are distinct, darker, cooler patches on the star that mark areas of extreme magnetic complexity. A solar maximum is a decade-long phase where the sun's magnetic structure is in a state of chaotic, explosive failure. Every explosion starts with a breaking point. When these highly pressurized magnetic bands stretch to their limit, they snap, unleashing a solar flare, an immense explosion of pure light and radiation. The snapping bands also launch a secondary, slower-moving threat known as a coronal mass ejection, or CME. These are massive clouds of charged particles expelled deep into space. Once launched, a CME crosses the 93 million-mile vacuum of space toward our planet at millions of miles per hour. That is exactly what happened in May 2024, when highly active regions on the sun fired a relentless volley of massive flares and particle clouds directly at Earth. A localized magnetic snap on a star takes just a few days to cross the solar system, instantly turning Earth into the target of the strongest geomagnetic storm we have seen in 2 decades. While these storms create beautiful atmospheric light shows, space weather is a severe kinetic threat to our way of life. Up in orbit, the atmosphere swells, creating drag that can pull satellites out of the sky. Severe space radiation also poses a direct danger to astronauts, complicating upcoming missions for Artemis, NASA's campaign to return humans to the moon. Down on the ground, the charged particles from these storms carry enough energy to severely disrupt GPS navigation, radio communications, and even overload terrestrial power grids. Our modern civilization relies heavily on delicate, interconnected technology. That reliance has turned a natural 11-year solar cycle into a critical terrestrial vulnerability. This chart maps solar activity over time, highlighting a supreme scientific irony. Scientists cannot identify the exact peak month until years after it happens. The peak is confirmed retrospectively once a consistent decline is tracked. NASA is aggressively trying to understand this chaos directly at the source. They are sending the Parker Solar Probe, closer to the sun than any human-made object in history, to study space weather where it originates. Astronomers have tracked these solar cycles for centuries, documenting the sun's violent changes. History proves that the danger is far from over, as some of the most devastating solar storms actually occur during the decline of the maximum. We live in the blast radius of an active, highly unpredictable star. The next massive flare could be launching right now.